Alright guys, so in this video we are going to do a quick review of simplifying radicals, and we're going to focus more on the square roots because when we are solving quadratics we have to be able to simplify radicals and do it pretty quickly. You'll see over here on the side I have put a list of our perfect squares from 2 to 12. To be able to simplify radicals quickly, we have got to be able to know these. We need to know these right off the top of our head, so I wanted to go ahead and write these down so we can reference them as we review. Now, I want to start off with this first example, really basic. I want to find the square root of 121. Now, what we should know is our first thing is we check and see, is that a perfect square? And 121 is. And so we can immediately know our answer. The square root of 121 is 11, since 11 squared is 121. Alright, so let's look at this next example. The square root of 50. Now, 50 we know is not a perfect square. So what we're going to do is we want to start thinking of those factors of the factors of 50, okay? But we only want those factors to be perfect squares. And we really want to think of the largest one if we can. So thinking about 50, a perfect square, that would be a factor, looking at all of our perfect squares over here. Hopefully we quickly see 25. So the square root of 50 can also be thought of as the square root of 25 times 2. There's this property that we learned, and it's the multiplication property of radicals. And that's when we can break these up, split it up into 2. We have the square root of 25 times the square root of 2. This is probably how I'll write them first thing from now on. We know that square root of 25 is 5, and then we're left with the square root of 2. And so this 5 square root of 2 is the square root of 50 in its simplest form. Now what about if we had a larger number here? What about the square root of 320? 320 is not a perfect square. If you were to try to find that in your calculator, you would get some decimals. So we've got to try and figure out the factors of 320. So if we were to start going through trying to divide 320 by some of our perfect squares over here, I'm actually going to go with a little bit of a bigger one. I feel like 16 should work. And so let's see what happens whenever we divide 320 by 16. Working that out, we get 20. And so what we know is if we break this apart, we should have the square root of 16. Let's see, there it is. The square root of 16 being multiplied by the square root of 20. Now at this point, I'm thinking I may not have found the largest perfect square. I know 16 is a perfect square, so what I need to do is I need to look at this 20. Is there a perfect square that goes into 20? And there is, 4. So what we need to do is we need to split this 20 up. We can split it up again. We have the square root of 16 times. Splitting up 20, the perfect square that goes into 20 is 4. So we have square root of 4 and the square root of 5. And we just simplify each of these radicals where the perfect squares are. Square root of 16 is 4 times square root of 4 is 2. And then we leave that square root of 5 just as it is. To get our final answer, I just need to take 4 times 2, which is 8, and we get 8 square root of 5. So what this tells us is if you don't identify the largest perfect square, it's okay. You just need to make sure that you check what's left and make sure there's not another perfect square that goes into it. Alright, so just like we did here, we ended up doing the splitting up twice, and we got our correct final answer. So what I want y'all to do is I want y'all to try 2 of these. I want y'all to try the square root of 54. And I also want you to try the square root of 252. And I'm just going to give y'all a few seconds to work these. I think y'all can do those pretty quickly. So go ahead and get going on that. Alright, so I'm going to go ahead and start looking at these with the square root of 54. If we try to divide 54 by some of these perfect squares, hopefully, you may even think about it right away. Perfect square that goes into it's 9. So we're going to have the square root of 9 times the square root of 6. The square root of 9 we know is 3. So the square root of 54 simplified is going to be 3 square root of 6. Alright, and with 252. Now, I don't know about you, but I wouldn't have maybe known the largest perfect square right away, so I would have started doing some trial and error, trying our different perfect squares over here, dividing those. So I would have probably taken 252, divided it by our first perfect square, which is 4. It gives us 63. So it does go in it. 4 is a factor, so let's go ahead and write that out. Square root of 4 times the square root of 63. Now what we need to do is figure out if 63 has a perfect square that goes into it. And it does, the square root of 9. So we have the square root of 4 times, splitting up the 63, we get the square root of 9 times the square root of 7. Since 9 and 7 multiply to give us 63. Taking these perfect squares, we get 2 times 3 and times the square root of 7. So 2 times 3 gives me 6, telling me that 252, the square root of that, simplified, is going to be 6 square root of 7.